everyone. In this video, we can see some numerical problems relating to string efficiency. First question. In a 33 kV overhead line, there are 3 units in the string of insulators. The capacitance between each insulator pin and the earth is 11% of self-capacitance of each insulator. Find the distribution of voltage over 3 insulators and string efficiency. Here a 33 kV overhead line is given. There are 3 units in string insulators. It is given that capacitance between each insulator and pin, that is shunt capacitance, is 11% of its self-capacitance. So the ratio shunt capacitance by self-capacitance K equal to 11 by 100, that is 0.11. We are asked to find out the distribution of voltage over 3 insulators, that is V1, V2 and V3, and also string efficiency. When we have derived the equation for string efficiency, we use Kirchhoff current law. According to that, at junction A, I2 equal to capital I1 plus small I1. Capital I1 is V1 omega C and small I1 is V1 omega Kc. The shunt capacitance is K into self capacitance, that is Kc. So, and I2 is V2 omega C. So, we will get V2 equal to V1 into 1 plus K. Value of K is 0.11. So, V2 equal to 1.11 into V1. Now, we can consider junction B. At junction B, I3 equal to capital I2 plus small I2. So, V3 omega C equal to V2 omega C plus, here the voltage across point B and the earth point is V1 plus V2. At this point and this earth point, the voltage is V1 plus V2. So, V1 plus V2 into K omega C. So, V3 equal to V2 plus V1 plus V2 into K. Substitute the value of K. Then we will get it as V3 equal to 1.34 to V1. Now, the voltage across whole string, that is V equal to V1 plus V2 plus V3. Substitute for V2 and V3 in terms of V1. Then we will get V equal to 3.45 to V1. In the question, it is given that it is a 33 kV overhead line. So, the voltage between phase and the neutral point is 33 by root 3. The given value is line voltage. So, the phase voltage is V line by root 3. 33 by root 3 is 19.05 kV. So, the voltage V is 19.05. So, we can find the value of V1. V1 equal to 19.05 by 3.5452, that is 5.42 kV. Now, from the equations of V2 and V3, we can find the values of V2 and V3. So, we got all the values or the voltages across each disk. Now, we can find the string efficiency. String efficiency is voltage across the string divided by number of insulators into V3. That is voltage across the disk near to the conductor. So, it is 19.05 is the total voltage divided by 3 disks. Number of insulators is 3 and V3 is 7.4. So, we got the string efficiency as 85.8%. Now, we can see next question. A 3-phase transmission line is being supported by 3 disc insulators. The potential across top unit or near to the tower and the middle unit are 8 kV and 11 kV respectively. Calculate the ratio of capacitance between pin and earth to the self-capacitance of each unit, the line voltage and string efficiency. Here we have to find out the value of K, ratio of capacitance between pin and earth and the self-capacitance. Here we have, in the question it is given that middle unit, that is V2, and the unit near to the tower, that is V1. V1 and V2 values are given as 8 and 11 kV. So, similar to previous question, I2 equal to I1 plus I2. and V2 is V1 into 1 plus K. So K equal to V2 minus V1 divided by V1. So here V2 and V1 are given. So we can find the value of K using this equation as 0.375. Now we can apply Kirchhoff current law at junction B and we can find the value of V3. V3 equal to V2 into V1 plus V2 into K. Substitute the value of K as obtained here and find the value of V3. Now we will get it as 18.12 kV. Then the voltage between line and earth is the total voltage is V1 plus V2 plus V3. We can add V1, V2 and V3. Then it is 37.12 kV. That is the phase to line voltage, earth voltage. So line voltage will be root 3 times 37.12 kV, that is 64.28 kV. Now we have string efficiency, that is voltage across the string, that is 37.12 divided by 3 into voltage across third insulator V3, that is 18.12. We will get the string efficiency as 68.28%. Here we have to find out the value of K so as to get the string efficiency. Here V1 and V2 are given in the question. Next question. Each line of three-phase system is suspended by a string of 3 similar insulators. If the voltage across the line unit is 17.5 kV. Calculate line to neutral voltage. Assume that the shunt capacitance between each insulator and earth is 1 by 8th of the capacitance of insulator itself. Also find the string efficiency. Here the voltage across the line unit, that is the voltage V3 is given. The voltage across the unit nearer to the line conductor, that is V3 is given as 17.5 kV. And here the value of K is given as 1 by 8, that is 0.125. So here we can find the value of V2 and V1 by using the value of V3. First apply Kirchhoff current law at junction A. Then V2 equal to V1 into 1 plus K. Substitute the value of K and find the relation between V2 and V1. At junction B, we can apply Kirchhoff current law. Then we will get the relation between V3 and V1. V3 equal to V2 into V1 plus V2 into K. Substituting for V2, we will get V3 equal to 1.39 V1. Now, voltage across top unit V1 equal to, from here V1 equal to V3 by 1.39. So V3 is 17.5 given in the question, divided by 1.39 we will get V1 as 12.59 kV. Then voltage across middle unit is V2, that is 1.125 into V1. So substitute for V1 obtained here. Then we will get the value of V2 as 14.16 kV. Then voltage between line and earth is V1 plus V2 plus V3. Add V1 and V2 and V3. Then we will get it as 44.25 kV. Now we can find the string efficiency, 44.25 by 3 into 17.5 into 100, that is 84.28%. Here the voltage V3 is given and we have to find the value of V1, V2 and the string efficiency. In the next question, there are 3 bus bar conductors in an outdoor substation are supported by units of post type insulators. Each unit consists of stack of 3-pin insulators fixed one on the top of other. The voltage across the lowest insulator is 13.1 kV. Here also V3 is given. Lowest insulator is V3. V3 is 13.1 kV. And across the next unit is 11 kV. Nearer to the lowest insulator, that is V2. V2 is also given as 11 kV. Find the bus bar voltage of the station. We are asked to find out the total voltage V. Total line voltage. Here V2 and V3 are given. So we can first write the equation between V2 and V1 at junction A. V2 equal to V1 into 1 plus K. So V1 equal to V2 by 1 plus K. V3 equal to at junction B, second junction, V3 equal to V2 plus V1 plus V2 into K. V1 substitute for V1 equal to V2 into V2 by 1 plus K, then we will get V3 equal to V2 plus V2 by 1 plus K plus V2 into K. So here we have an equation. Here K value is not given. So our aim is to find the value of K. We have V3 and V2 values given in the question. Substitute for V3 and V2 and find the value of K by solving this equation. The equation will be simplified as 11K square plus 19.9K minus 2.1 equal to 0. Solving that equation, we get the value of K as K equal to 0.1. Then substitute for K to find the value of V1. V1 equal to V2 by 1 plus K. So V1 equal to 10 kV. V2 value is given in the question. So we are asked to find out the bus bar voltage, that is V1 plus V2 plus V3. 10 plus 11 plus 13.1 is 34.1 kV. Then the bus bar voltage will be expressed as line value. The obtained value is phase value. So we have to multiply it with root 3 to get the line value. The line value is 59 kV. In the next question, we have a string of 4 insulators has a self-capacitance equal to 10 times the pin to earth capacitance. Find the voltage distribution across various units expressed as a percentage of total voltage across the string and string efficiency. If number of, here up to these problems we have discussed with 3 insulators. If number of disc insulators are increased, it is difficult to apply Kirchhoff current law at each point and solving the problem to find the string efficiency. At that case, we will be assuming a value of current at the first insulator. The current will be assumed as 1 ampere at the insulator near to the tower. Then we will apply Kirchhoff current law and find the values of currents at each insulator. We can see this problem. When the number of insulators exceed 3, nodal equation method is very laborious, so we can use this method. Here K value is given. It is given that self-capacitance equal to 10 times the pin to earth capacitance. So C by C1 is 10. So we can first take XC as 1 ohm. Here XC as 1 ohm. Self-capacitance of 1 ohm. Then shunt capacitance will be 10 ohm. We can assume the current through first element as 1 ampere. And since the ratio of shunt capacitance to mutual capacitance is 10, we can consider that this capacitance is 10 ohm and self capacitance is 1 ohm. So the voltage across first disc is 1 ampere into 1 ohm, that is 1 volt. Now we can find the current through the shunt element of first disc. That is the voltage across this shunt element divided by 10 ohm. That is 1 volt divided by 10 ohm is 0.1 ampere. Now the current I2 is I1 plus I1. 1 plus 0.1 is 1.1 ampere. Now the voltage across second disc is 1.1 into 1 ohm, that is 1.1 volt. And current through the shunt element of second disc is the voltage across the shunt element, that is V1 plus V2. 1 plus 1.1 divided by 10. 2.1 divided by 10, that is 0.21 ampere. Then the current I3 is 1.1 plus 0.21 is 1.31 ampere and the voltage is 1.31 volt. Then we can consider third element. The voltage across the shunt element is V1 plus V2 plus V3. 1 plus 1.1 plus 1.31 is 3.4 divided by 10 is 0.34 ampere. Then the total current I4 is 1.31 plus 0.34, 1.65 ampere, and the voltage is 1.65 volt. Now we can find the voltage across each unit expressed as a percentage of total voltage. Total voltage is 1 plus 1.1 plus 1.31 plus 1.65 is 5.06 volt. So first voltage across top unit is 1 by 5.06 into 100. That is 19.76%. Second unit is 1.1 by 5.06 into 100, 21.74%. And third unit is 1.31 by 5.06 into 100, 25.9%. And fourth unit is 1.65 by 5.06 into 100, 32.6%. So we have found out the voltages as a percentage of total voltage for each unit. Now we can find the string efficiency. Total voltage is 5.06 divided by number of discs is 4 into voltage of lowest disc, that is 1.65 into 100, that is 76.6%. So if we have disc more than 3, we can use this method for calculating the string efficiency. Here we will get the voltage across each string as a percentage of total voltage. So in this video we have seen different problems relating to string efficiency. Thank you.